Hi, Integrated Math 1. Welcome to lesson 2.1.5b, where we are comparing linear functions in different forms. So if you recall, we've been comparing our linear functions represented as equations algebraically or graphically or with tables or with verbal descriptions. We've been making sure that we choose and interpret appropriate units to represent our independent and dependent quantities, right? Make sure you got your units on there. And we've also been choosing and interpreting appropriate scales and origins for our graphs of linear functions, right? What's our y-intercept? All that good stuff. We've been playing with that. So we're going to keep playing with it. We've been representing our linear functions in a variety of ways, and we've been comparing these different representations. We're going to dig a little deeper today. So today we're on page 77. We're going to compare equations and tables a little bit. So Josh and Greg are friends who live in different countries. When they chat online and talk about the weather, one of them always uses temperature in degrees Celsius, while the other talks about temperature using degrees Fahrenheit. I know their pain. I talked to a lot of my friends back in Australia, and I'm using Fahrenheit scale here in the United States. They are using the Celsius scale back in Sydney. So that's a problem. And yes, we have to constantly be working this out. So Josh uses an equation to convert Greg's temperatures, and Greg looks at a table to convert Josh's temperatures. The equation and part of the table are shown. So this is a tricky one. Identify the quantities in the table and equation. Who's converting from degrees Celsius to degrees Fahrenheit, and who's converting from degrees Fahrenheit to degrees Celsius? Explain your thinking on this. That does mean that you might want to label your table a little bit and maybe even make a little note of like what's X, what's J, all that good stuff. So go ahead and hit pause. See if you can figure this out and then hit play when you're ready to check your work. So I was thinking about this and I thought, okay, well, water freezes at 0 degrees Fahrenheit. But that's 32 degrees. Pardon me, I'm going to try that again. Water freezes at 0 degrees Celsius, which is 32 degrees Fahrenheit. And so my thinking on this is, okay, the Celsius degrees are going to be smaller than my Fahrenheit degrees. My Celsius degrees are going to be less than my Fahrenheit degrees. So I started with Greg's table, and I was like, okay, that means the bigger numbers are degrees Fahrenheit, the smaller numbers are degrees Celsius. So that's where I kind of started my thinking on this. So I thought to myself, okay, well, Greg's input is Fahrenheit and his output is Celsius. So that means Josh is going to be the other way around, right? Josh has to go the other way. So Josh's input is going to be Celsius and his output is going to be Fahrenheit. Fair enough. So that means Greg is converting from Fahrenheit to Celsius. Josh is converting from, pardon me, I'm going to do this again. Greg is converting, from Fahrenheit to Celsius. Josh is converting from Celsius, inputting Celsius, and going to Fahrenheit. Yeah. So Greg's going Fahrenheit to Celsius. Josh is going Celsius to Fahrenheit. I would like you to compare the slopes, the intercepts, compare all the things. Start off with the slope. Hit pause, work this out, hit play when you're ready to check your work. So slopes are easy, right? I mean, I can easily find the slopes. Like, for example, this slope is so easy to find. Look at that. The slope is like 9 fifths. Okay, that made it easy and nice. So the rate of change for Josh is 9 fifths. I can see that. For every 5 degrees increase in Celsius, there's a 9-degree increase in Fahrenheit. Well, if Greg is going the other way, then if Josh is going 9 over 5, Greg's going the other way, right? He's going the opposite. So that means Greg's rate of change is going to be 5/9. For every 9 degrees increase in Fahrenheit, there's a 5-degree increase in Celsius. If Greg's going backwards from Josh, right, then we got to flip that. Oh, the y-intercept is trickier. But Josh's y-intercept is easy to find, right? We're just looking at this and we're like, Josh's y-intercept is 32. Thank you for making that easy, Josh. So that means 0 degrees Celsius is 32 degrees Fahrenheit. Now, this one was hard. And for Greg's y-intercept, and I really had to think about this. I was like, okay, 0 degrees Fahrenheit would give me what? And I'm not going to lie. I maybe had to cheat a little bit and go online and be like, 0 degrees Fahrenheit is how many degrees Celsius? And I found out that 0 degrees Fahrenheit is actually negative 17.75 degrees Celsius. It's freaking cold, is what it is. Cold. It's cold. Let's do our next activity. Now I'm cold. Page 78, we're going to compare descriptions and graphs. So Michelle and Dondre both opened bank accounts at the same time. Dondre's account balance is shown in the graph. He started with $0 and deposited the same amount each month. In the 4th month, he had $80 saved. You might want to make a note of that in the 4th month, so that's month 4, he had $80 saved. I'm just saying that might become important. Michelle opened her bank account on September 1st, same day, but she started with $25 in the account and continues to deposit $25 each month. Can you finish off this graph? Can you finish off the graph and interpret the origin real quick? Hit pause, write it down, hit play when you're ready to check your work. So I hope you got the hint earlier, right? 4th month, so this is our months 1, 2, 3, 4. $80, so this is our dollars. And if I count properly, if that's 80, it looks like we're counting by tens on the graph. So that would be 20, 40, 60, 80. So yeah, our x-axis is the number of months, our y-axis is the money saved, and we've put numbers on this thing to preserve our sanity. That means that at month 0, we had $0, which is fair because we said Dondre had no money when he started, right? Dondre had $0 when he opened the account. All right. Compare the slope, compare the y-intercept, all that good stuff. Go ahead and hit pause, work this out, hit play when you're ready to check your work. All right, so let's talk slope. Well, it looks like Dondre is adding $20 each month. So I'm going to say Dondre's rate of change is $20 because he saves $20 a month. Ooh, but now that I figured out Dondre's slope and that it's a whole $20 per month thing, that actually helps me figure out what Michelle's slope is, what Michelle's rate of change is, because Michelle is depositing $25 per month. So her rate of change is $25. 25. You get the idea. Y-intercepts. Well, we said earlier the y-intercept here for Dondre was 0, and it meant that's how much he started with, right? So the y-intercept for Dondre's account is 0 because he started his bank account with $0. Michelle, though, started her bank account with 25. So her y-intercept is $25 because she started with $25 in her account. Wow, that was actually kind of easy. That wasn't bad at all. I hope you found this helpful. I hope you found this useful. If you have questions or concerns, please email me, come talk to me during lunch, office hours. I'm around, and I'll see you guys soon. Bye.